Section 9.3, Confidence and Prediction Intervals, Video 5. In the previous video, we used these three computer outputs to calculate a confidence interval, a 95% confidence interval, for the mean tip when a bill is $30. Just a reminder, the first computer output are the summary statistics, which contains how many of each value, the mean and the standard deviation of each variable, the regression output from which we can build the regression equation, and the ANOVA table from which we really only needed one value, the MS error. I've preserved a lot of the work from the previous calculations to show you that we don't have to totally reinvent the wheel when we do a prediction interval following a confidence interval. I've left a lot of stuff up there, but I've changed some things to red. For example, I changed the word the word confidence to prediction. And I went ahead and amended the formula for the standard error with the 1 plus under the square root. Everything prior to that is still the same. The t is still the same. The standard deviation of errors is still the same, which is why it's still 0.9795. So I'm going to recalculate the standard error, recalculate the margin of error, which still has the same value for t here. I don't have to recalculate the predicted tip when the bill is $30, that stays the same. But I will have to change the margin of error when I calculate the interval. So let's recalculate, and I invite you to pause the video, I should have done this in the other one, and see if you can calculate this standard error, and then see if we get the same answer. I'm gonna go ahead and calculate it. Again, from my experiences with calculators, I know the best way to attack some of these. In this case, I would go all the way to the inside of this big fraction, do it first, then add this fraction, then add 1, then square root it, and then multiply times this number. It's almost like you're following the order of operations. Here we go. Parentheses 30 minus 22.73 close parentheses squared divided by parentheses 156 times 12.16 squared close parentheses equals. Now I'm going to add 1 divided by 157 equals. Now I'm going to add 1 equals, now I'm going to square root that, equals, and now I'm going to multiply it times 0.9795 equals. And I get 0.9837. I don't remember what the previous standard error was, but I know it was noticeably smaller than that. So excuse me, I said I was going to write new stuff in red. That's new. It's not in red. Give me 1 second to fix that. Okay. 0.9837. By the way, if you did this in your own calculator, did you get that value? If not, maybe you did it right and I did it wrong. So I'm going to do it one more time. This time I'm just going to type it in from left to right. Carefully, because I'm skilled like that. It's always a good idea to recheck your calculator work, especially when you're using a massive formula like this one. I got the exact same value for the standard error, so I'm feeling pretty confident about it. Okay. So our margin of error is the original t value times the new standard error. And if we multiply those, we get, did I type that right? I did, 1.9281. If I recall correctly, the previous margin of error was around 17 cents. So if we take that margin of error and use it to create our interval, let's see what that's going to be. 5.168 minus 1.9281 is equal to 3.2399. And if we add instead of subtract, we get 7.0961. But again, we're trying to come up with an interval to capture 95% of the tip amounts when a bill is $30. So if we round this to the nearest cent, we get 3.24 and 7.10. So what this answer says is, if we were to look at all bills ever that were $30, we predict that 95% of the tip values would be between $3.24 and $7.10. I don't remember what the prediction interval was earlier. It was $3.23 and $7.12. So our calculations were 2 cents off. That doesn't mean we're wrong. That doesn't mean they're wrong. That means that there was probably a rounding issue somewhere. If I were to recalculate all of this without any rounding at all, starting here, this MSE value is rounded off if you divide these. If we would use the exact value there, the exact value here, the exact value all the way down, I think we would have compensated for the 1 cent discrepancy. 1 cent discrepancy. They got $3.23, which was a 1 cent discrepancy, and over here they got $7.12. I'm not going to argue the minor points of rounding between the beginning and the end, causing slightly different answers. If this were a test question and you wrote all this down, you would get full credit. All right, so it's just like calculating a confidence interval, except there's a 1 plus here, and the answer means something different. We predict that 95% of tips, when a bill is $30, will be between these two values.